Hey, geometry. Now we're going to look at the next step beyond points, lines, and planes. The next kind of most basic thing we've got is angles. And so that's where we're going to jump into first. So 1.3 got ultimately called measuring angles, but we're going to first define an angle. An angle is two rays with a common endpoint. We call that endpoint the vertex. So the vertex of an angle is that little, basically the corner. So it is that common endpoint. And we call the two rays the sides of the angle. So the sides of the angle are the rays. Are the rays. So naming an angle, we have a couple of different names. We can name it by its vertex. So if I have an angle like this, we can just, and if it's labeled there, sometimes we'll label it by its vertex. So if that's point A, we'll just call it angle A. And so we just use this little like angle symbol. It's kind of like a less than sign, but it's not pointing straight sideways. It's kind of like flat with that angled up. But that would be angle A. Sometimes we'll label an angle in a shape or something like that with a number. So I might call that angle, maybe that's a 1 there. So this would be angle 1. And so that's another way that we can label an angle. And then a third way is we can label it by a point on each ray and the vertex. So if I've got an angle like this, especially if let's say there's actually another thing in here. So I've got, we'll say that this is A, and then this will be B, and then this point here is C. So B is going to be my vertex, and maybe this is the angle I want to talk about, but there's this other ray going there in the middle. So if I want to refer to this outer angle here, I would call that angle A, B, C. I can't just call it angle B because there's actually 3 different angles occurring at B. I've got this little angle up here, I've got this little angle down there, and then I've got that bigger angle. So if I want to talk about that bigger angle, if that's kind of what we're focusing on here, we would call that angle ABC. You do need to get the vertex as the middle of those 3. I also could have called that angle CBA. All right, so then if we want to do the measure of an angle, we do this little M in front of that angle symbol. So that is the measure of an angle. And we'll start measuring in degrees. There are other ways to measure angles, but we'll measure in degrees. And so the measure of angle dog is 52 degrees. And so that's actually a number. And so when we get back to this idea of equal versus congruent, angle measures can be equal, whereas the angles themselves can be congruent if their measures are equal. So angle dog is just referring to the angle, kind of the picture there. So that's the actual angle, whereas the measure of the angle is the actual, just the number 52 degrees is what the measure of that angle is. So here, if measure of angle A is 70 degrees, so if this is 70 degrees, and measure of BCA is also 70 degrees, so we can write that statement that the measure of angle A is equal to the measure of angle BCA. And I got kind of weird labeling that one. You would usually stay consistent. You would call this angle C in that case, but just showing you a couple of different ways it could be named. You could have also called this BAC or CAB. Whereas in this case, if I'm saying that angle 1 is congruent to angle 2, so what's meant here, if this is isosceles, so those 2 segments are congruent, but then also these angles are congruent to each other. We can actually mark that with little angle symbols, little arcs, angle symbols, and then you can mark those as congruent as well. But that would be like angle 1 and angle 2. And so we can say that angle 1 is congruent to angle 2. All right, I don't know that we're going to be doing this. You don't need to get protractors, but I don't know, maybe I'll have you do this digitally at some point. But hopefully you've kind of messed with the protractor before in terms of measuring an angle. So I'm trying to measure this angle here. Use our protractor. You center that hole on the vertex, line up the bottom, this little line down here with the bottom, and then basically see where that line points to. And sometimes it can help to extend that line a little bit. So I extend that line a little bit so I can see just where it's going. So if I get that vertex lined up and go there. So we have to realize, all right, so you know, if it were going straight in the same direction, that would be a 0 degree angle. And so we go up to 10, 20, 30, 40. So there's two different ways, whether you're measuring from the right or the left. So from the right here, we're on the inside. And so it looks like we're at about 45 degrees, maybe a little off there, maybe 44 degrees would be my estimate for that. I don't know how well you can see that, the 5 tick marks right there. So I'd call that probably a 44 degree angle, but I might be off by a degree. On this one, I can turn my protractor this way and measure it that way in the same direction, or I can measure kind of going up the other way, and I would use the outside arc here. So let me see if I can. So if I put that vertex on there and measure up here, this looks to be pointing up this way at about, what is that? That's probably 10, 20, 30, 40, all the way up to 100, and looks like maybe 104 degrees. And I could draw that line out a little bit better, but we'll put that in there as the estimate. All right, so then we can classify angles. We can classify angles as acute. So that would be angles that are less than 90, less than 90. They are cute little angles, so something like that is less than 90 degrees. We have the right angle, which is equal to 90 degrees, all right? So that would be straight out. It's like the corner of a rectangle or square. So a 90 degree angle. And we show that it is a right angle by putting like a little like square mark symbol in the corner there for that angle. But that would be a 90 degree angle. Definitely the most common angle you'll see, at least in human construction. Between 90 and 180 for the obtuse. So between 90 degrees and 180 degrees. So in between those two, so an obtuse angle would look like maybe bigger than that 90 degree angle. And then we have the straight angle, which is always a weird one, but it is equal to 180 degrees. And it just looks like a line. But if you had like ABC or whatever, that would be called a straight angle. Not always that useful or interesting. But that's the start of angles. We'll get back to this in the next video.